Hi you guys, today we're going to take a look at your ANCOVA assignment, and ANCOVA stands for Analysis of Covariance. And when trying to pick out the material for this course, I kind of debated what I should include for ANCOVA and repeated measures ANOVA. And I think I decided that rather than use one and not the other, I was going to give you kind of a quick introduction to both. So ANCOVA and repeated measures ANOVA are both kind of more advanced ANOVA analyses, and this is not a real advanced class, so we're going to hit the highlights and not get into a lot of the details, but I wanted you to at least be aware that this type of analysis exists. You might read about it, and you'll know some of the basics of what you're looking for, but also be aware that it can get complicated. So last time we looked at a two-way ANOVA, and just like a one-way ANOVA, we had our categorical predictors in there, except we had two, and we had an additional term that showed up because we included two categorical predictors, and that was the interaction between them. Again, this is only a one semester class. We're not going to get into more complicated things, but I guess be aware that the more variables you add to an ANOVA, the more complicated it gets. So ANCOVA, this time we're going to look at, instead of two categorical predictors, we're going to have our one categorical predictor, but we're going to add an additional variable that is continuous, and that is going to be called the covariate. And what this is for is if you have an additional variable that you think is related to the outcome variable, and you want to try to control for it, or see the effect of your independent variable while controlling for this additional variable that is related to the outcome variable, the dependent variable. And ANCOVA is our way to do that. So again, I have the answer sheet for this week. Go ahead and put your name on that. And we have the modules that we've had before, but notice there is a new one down here at the bottom called the SCATR scatter module, and just follow the instructions to and make sure you install that before you do this assignment. We're going to use that one also, and what that does is under the modules you'll see scatter there, and it adds an additional scatter plot to under our exploration menu. So we have this scatter plot that we can use now, and we're going to use that as part of this analysis. So we have our standard steps that we need to accomplish before we do a statistical analysis. So we're going to check for some data accuracy, look at our different variables, what's the level of measurement, scoring instruments if we had any, and keeping list of what we did so that we can report it with results. Also look for any missing data and outliers. So why don't we go ahead and look at this data set really quick. Make sure you read through your chapter to see what this data set is. Field describes it, and it's a data set called Puppy Love, and I've already got this open in Jamovi. So let's go ahead and click on the Data tab and look at our different variables. So the first one is a person variable. It is a participant ID, and I would actually put that as an ID type in Jamovi. I don't think SPSS has a different ID type, but since we have Jamovi, let's go ahead and mark the correct variable type. And then you can either click on the column header or click on the navigation arrows, but our next variable is called dose, and we can see that we have 3 levels. It's a control that doesn't get any time with puppies, another group that gets 15 minutes, and another group that gets 30 minutes, and that would actually be an ordinal level of measurement, but nominal and ordinal are both categorical variables, which is what we need for our independent variable on our ANCOVA, so we'd be okay leaving it, but I'll go ahead and change it to ordinal. We have the happiness variable that we looked at last time, and again, he's calling this a continuous measurement. If I were actually assigning a level of measurement, there's less than 10 groups here. There is order to the observations. Looks like there's 7 groups, so I would actually call that ordinal, but I will leave it as continuous for the purpose of this example. And we have an additional variable, which is how much people love puppies, and again, it's another rating scale on a scale of 1 to 7. If I were assigning a level of measurement, I'd call it ordinal, but we're using it as a continuous variable for this example, so I'll leave it alone. So this is a small data set. We can see all the variables and very quickly scroll through the entire all the rows, and we can tell that we don't have any missing data. I don't see any extreme values or any groups that are different. But if this were a bigger data set, we would look at our descriptive statistics. So let's go ahead and go into analyses and exploration and descriptives. And if we were going to look at dose, again, we've decided that dose is a categorical variable, so the appropriate descriptive statistic for that is a frequency in a percent. And so let's go ahead and put dose in the variable that we want to see. Let's get frequency tables, which gives us our frequencies and our percents. And with a categorical variable, we don't care about seeing means and medians. We still want to see how many in each group, and if there's any missing data, and we don't have any there. And let's see, is there anything else? We can get rid of this minimum and maximum, and that's pretty much what we'd want to see on our categorical variables. So I'll go ahead and close this out so we can keep that, and we'll go back into analyses and exploration and descriptives, and let's look at our continuous variables, and that's going to be happiness and love. And again, I already know that I'm doing an ANCOVA. I care about my normality assumption, so I'm going to go ahead and split this into groups by putting dose into the split by column, because when we're looking at normality, we really care about is it normally distributed in each group and not just overall. We're already getting mean and median. We can look at our skewness, and we'll go ahead and get our Shapiro-Wilk normality test. We'll get our standard deviation, and that's probably I guess I could have gotten a plot. So let's go ahead on this one, and for our continuous variables, histogram and a box plot are the appropriate plots that we would get along with our means and standard deviations. and see what comes up here. And things are a little more spread out for these. This doesn't look normally distributed. We can include the density function on these, and you'll see that these curves don't really look like they're normally distributed when that comes up. So definitely have some issues with normality here, and we'll see our I don't see any outliers on the box plots. We can go up and look at our statistic test, our normality test, Shapiro-Wilk. None of them are significant, and that's pretty much because we have small sample sizes here. If they were much larger, they would be significant. Skewness divided by the standard error, the skewness is also less than 2. So we're okay, but this is a small sample size, so it's not fantastic. I did forget to get the plots on this frequency distribution, so we can go back to that. And with the categorical variable, the appropriate plot would be a bar plot. And this is one thing I like about Jamovi, is the ability to go back to a previous section and add something in that we forgot to do. Here's a bar plot of our categories, and in SPSS, once you run it, your output actually comes up separately, and if you forget something, you can go back and run the whole thing again, and now you have it duplicated in your output, and it's kind of a pain to go clean up your output too. So a lot of times you'd end up with some pretty long output, and you'd have to kind of remember what section had what you wanted. So this is one nice part of Jamovi. They've laid this out nicely, and it's easy to go fix something after you've looked at it. So we don't have any missing data. We have our 3 groups, and everything looks okay, and we can move forward with our other looking at the other parts of our plot. And we did look at normality. We do know that now that we're getting down to closer to looking at our statistical assumptions, we still have our observations are independent assumption, and we only know that if we know the study design, which we do know that these were different individuals divided into different groups. So we met that assumption, but you do need to know how the data were collected to really be able to assess if you meet that assumption or not. We looked at our normality assumption, and the actual assumption is that our sampling distribution is normally distributed in the population, and we don't really have access to that. So as a proxy, we do look at the normality of our data in each group. We know that there would be issues if there were a larger sample size, but we met the assumption. That's probably one of the weaker parts of this test if I were really being rigorous about it. Homogeneity of variance, we know that we get that using Levine's test, and we can check that option when we go run the test. And we have a new assumption here for analysis of covariance, and the assumption is that the independent variable and the covariate are independent of each other. So if we go look in Jamovi, and let's just look at our variables, and this is where you really have to start understanding what each variable is doing in your data set. And we know we have our outcome variable, and that's probably the easiest one to pick first, was our happiness variable, and that's the same. That's our dependent variable, is happiness. If we look at our assumption, what we're interested in is the independent variable and the covariate. So the independent variable is how much puppy therapy they got, how much time they had. And we know that one's categorical. and we know that our puppy love, how much they love puppies, is our covariate. And we know that that one's continuous. So if we went and looked at the mean of each of those groups, trying to look at this, we can see that they're not exactly the same. The control group had a mean puppy love score of 3.44. The 15-minute group had 3.13, and the 30-minute group had a 2.0. So there are some differences in those means, and the question becomes, are those differences significant? And we do know a test that we can look at to look and see where we have a categorical variable and a continuous variable, and that is our one-way ANOVA. So rather than just do an eyeball test of the means, we know there's some difference there, but the question becomes, is it statistically significant? We can actually do a test. So let's go to assess this independent variable and covariate independence. Let's go run our one-way ANOVA, and our grouping variable is going to be dose, and our dependent variable in this case is going to be puppy love. And if we look at that, we run the ANOVA, we can see that our p-value is greater than 0.05, and we would know that the differences in those means is not statistically significant. So that is a way that we can test our independence assumption for ANCOVA. And as you can tell, running an ANCOVA is quite a bit more complicated than just running a regular ANOVA, because here we're still assessing assumptions, and we ran one test to test our independence assumption. Now we're going to actually go test our homogeneity of regression slopes assumption. So, and we haven't really gotten into correlations or regressions yet, but we can get a quick idea of what it's talking about by looking at a scatter plot. And if we went ahead and used our two continuous variables, happiness on the x-axis and puppy love on the y-axis, we can see that we have these points plotted out for these two variables, and we're going to add in a regression line. And basically it tells us, it gives us an idea of what's the relationship between these two variables, and we see that this line slopes upward a little bit, and there is some relationship there, but we can actually go test this assumption with a statistical test, and that's what we're going to do before we go run the ANCOVA. So I'm going to leave this plot here. We can see there is some kind of relationship. If there were no relationship at all, this line would be pretty much horizontal. It would be flat, and that would tell us there weren't a relationship. There's a slight one there, and we're going to go see if it's a significant relationship. And ANCOVA is a test where it's almost like we actually run this twice. So we're going to get into our ANCOVA menu, realizing that this first time through, we're actually just testing our homogeneity of regression slope assumption. Our dependent variable is still going to be happiness. Our fixed factor is going to be dose. And now we're going to put our puppy love in as a covariate. And this covariate box is a new one for us. We haven't used this yet, and this is a continuous predictor variable in an ANCOVA. Remember that a factor is a variable that divides people into groups, so it wouldn't really be appropriate to put puppy love, which is continuous, into our factor box, but dose, our independent variable, which is 3 groups, does go in there. And I'm not really going to get a lot of other options, but I am going to go to this model section. And you'll notice that Jamovi has put in 2 terms of our model, dose and puppy love. We actually need to add an additional term, and that is an interaction between our independent variable and our covariate. And the way we get that interaction is we use the control button and select both variables. So you see them both highlighted. And then we're going to use this bottom arrow button and tell it that we want the interaction. And now it puts this interaction term in here. And up to this point, the ANOVAs and the t-test that we've looked at, we've had a little more wiggle room with our assumptions of normality and homogeneity of variance. Field really seems of the opinion that the homogeneity of variance assumption is not that important, and ANOVA is pretty robust against that assumption. We also have some wiggle room with ANOVA. This homogeneity of regression slope is a pretty important assumption, and this is probably the one, if we violate, it's the biggest deal for the results of this test. And if we come here and look at this ANCOVA table, we can see our interaction term, and we actually see that it is statistically significant. This is probably one test where this is kind of a deal breaker. If I were considering an ANCOVA for my analysis here, I would actually really rethink that. And Field did mention, he used this as a sample data set. He mentioned there might be some circumstances where you can still want to see the results of this, but this you ought to almost consider this as a deal breaker for being able to use ANCOVA. We're going to continue on with our test so we can see how the results would go, but if I were analyzing these data as part of a study, then I would probably reconsider that and not use an ANCOVA. I might analyze parts of the data set separately. There are some other more complex statistical analyses, and they are really more complex, and you'd want to get the help of a statistician who has a degree in statistics, or somebody who has a lot of experience analyzing data to move forward from here. So be aware that this really is an important assumption, this homogeneity of regression slope. And this significant test right here is enough to see, but I really think this makes sense, more sense when we actually look at a plot of it. And we did something similar last time when we looked at our two-way ANOVA interaction, and the way we really interpreted that was using a plot. So I'm actually going to go back to this scatter plot, and let's add our dose in as a group. And what that does is going to take our 2 variables that we had to begin with and split those data points up into their individual groups and make a line out of each one of those, because we included this regression line. And homogeneity means the same, and regression slope is that line that we looked at. And when we look at this, we can see that the control group is our blue line, and there's the slope of our blue line, and our gray line is our 15-minute group. Those slopes are pretty similar. The 15-minute group might be a little more steep. If these lines went on for a longer distance, they would probably eventually cross each other. But here's our 30-minute group, and we can see that that slope is definitely not the same as the other two, and in fact it does cross both of those. So while these two rise from left to right, this one actually descends from left to right. And this is what our significant interaction was telling us, was that for different levels of our dose group, that the relationship between these two continuous variables, happiness and puppy love, are not the same. And that's why that interaction is significant. And just like our other interaction, this really is easier to see what this is really talking about by getting this plot. And I think this scatter plot was really the easiest way to look at that. So if I were doing this for real, I'd pretty much stop with my ANCOVA at that point and decide we needed to go a different direction for looking at the data. But we're going to go ahead and run it just so we can see how an ANCOVA is done. So now that we have run this the first time, we're going to actually go ahead and go to ANOVA and ANCOVA again, and we're going to run a different one. And this time we're going to run a regular ANCOVA without including our interaction. So our dependent variable is still happiness. Our fixed factor is dose. And our covariate is puppy love. Since we're running the actual ANCOVA, I'm going to go ahead and select a partial eta squared. That's the effect size that I pretty much learned with ANOVAs. Although Field does say that the omega is less biased, so I think he makes a fine justification for that. If you want to, you really only need to report one effect size. And I'm going to go ahead and stick with partial eta squared because that's what I'm used to. But if you wanted to go with the omega and get the square root of the omega squared and report that in sight field, I think that's perfectly justifiable. So, if I were doing this, I might actually consider switching that, but I'll leave it with partial eta squared. We know our model doesn't include the interaction term, and that's fine, because now we're running the regular ANCOVA. Assumption checks. Let's go ahead and select all three options because we're going to look at our homogeneity of variance test. That was still an assumption that we have because we have groups. And I'm not going to worry about contrast, but under post hoc tests, let's go ahead and get dose. And we can just get a Tukey. Again, this was an ANOVA post hoc test. No correction in the field text and in SPSS. That's called the LSD option. It stands for least significant difference, and they just labeled it with no correction, meaning that they just gave p-values without correcting for them. Tukey is kind of a middle of the road option. That's the one I use the most often. Bonferroni is the most conservative, and that's basically taking the number of tests that you do and dividing your p-value of 0.05 by the number of tests that you're conducting. And we could go ahead and select the effect size. And then we're going to get this estimated marginal means. We're going to select dose and move it over to the marginal means box under term 1, and we will talk about what that means. And I think that output, we're going to get this marginal mean plot. We're going to go ahead and get the table that goes with it. Error bars we can leave as confidence interval, and we'll leave this other option of equal cell weights how it is. Okay, so now looking at our ANCOVA, what we really care about is our independent variable. And the question, if I were running this test, we can go down to our section looking for running our statistical tests. So in the assignment, I have your steps for null hypothesis significance testing. If we were doing this for real, we would have decided upon a research question and research hypotheses, and then we would have determined the appropriate data to collect, and what kind of a test we should do on that. We'd collect our data, and then we would be ready to do our statistical testing. And since we have a data set already, basically these first three steps were done for us. The null and alternative hypothesis. So for the ANCOVA, each of these effects will have a null and alternative hypothesis. So for dose, we would say that there is no difference in the outcome variable, which is happiness, for different levels of dose. So there is no difference between the groups. The alternative would be there is a difference. Puppy love, we would say there is no relationship between puppy love and our outcome variable of happiness, and the alternative would be there is a relationship. And as we know, we have these two independent variables, and we actually earlier tested this interaction to assess our homogeneity of regression slope assumption, and the null would be there is no interaction, and the alternative would be there is an interaction. And we already looked at that, and we do know that that was significant. And again, if I were doing this for real, I would probably stop right there. But so we can see how to do the ANCOVA. We really don't care so much about this test of the covariate. So really all we care about in the ANCOVA is this, and once we've assessed our assumptions, is this independent variable of dose. And we're going to see if our p-value is less than 0.05, which is our criteria of rejection, which we already are selecting for this class and using 0.05. So we already had that selected. And then we have our test statistic here. And we would know that our p is 0.027, which is less than our criteria for rejection of 0.05. And we would reject the null and say that there is a difference in happiness levels for dose groups. And then we would, well, I guess we didn't interpret Levine's. We see Levine's as 0.5, which is not less than 0.05, so we meet our homogeneity variance assumption, and we're okay on our normality test. It's a little off, but it's pretty close to the line. And our post-hoc tests, we do have our group comparisons between our control and our 15-minute group, and we can see that between our control and our 15-minute group, it is not statistically significantly different. Between our control and our 30-minute group, it is significantly different, and between our 15 and our 30-minute group, it is not statistically significant on the difference. And you can see that the control and the 15-minute group on this plot, there is some difference there, but apparently it's not enough to be statistically significant. Between the 15 and the 30-minute group, there's less of a difference there, and not surprisingly, it's not significant. But between the control and 30-minute group, that difference is statistically significant. The other special thing about the ANCOVA is when we looked at our descriptive statistics before, and let's go up and look at them. And we get back up to our happiness means, we can see that our mean for the control group was 3.22, and for the 15-minute group 4.88 and 4.85. So, however, these are not the means that we would report for our output on our ANCOVA, because these are unadjusted, and we are actually adjusting our means for our covariate. If we go down and look at these estimated marginal means, we will see that these means do not match what was in our unadjusted means up above. So 2.93, 4.71, 5.15, there's definitely a difference there for from our regular means, and we would actually want to report the adjusted means that we get from our estimated marginal means from our ANCOVA results. And this is one area where I actually preferred the SPSS output a little bit. If you go look at page 437 in the field text, you'll see that these output, this estimated marginal means, these match the means that we have in our output 13.7 on page 437 in the field text. So we do have, there's just a rounding difference here. He rounded at 3 decimal places, or SPSS rounded at 3 decimal places, and Jamovi rounded at 2. 2 is perfectly fine to report. There's no reason that thousandths decimal place needs to be given to a reader. It doesn't make any difference to them. And what I did like a little better about the SPSS output is you'll notice that the SPSS output in the book says that the covariates appearing in the model are evaluated at the following values: love of puppies equals 2.73. And these are adjusted means controlling for the covariate, but they don't really tell us what value of the covariate. At one point they're adjusting these means. And what this means, and we can kind of look at our scatter plot and take a little look at this that we had before. And I probably, maybe I could have oriented this differently, but this puppy love variable is our covariate. And whenever we see these 3 variables in here, we see that each of these groups is split out. And what is going on here is that we would actually be looking at these means where they crossed the where they were at the mean of puppy love. And so if we went and looked at our descriptive statistics for puppy love, where SPSS got that 2.73 from is, if we went into exploration and descriptives and we just got puppy love, and if we looked at the mean for that, you'll see that the mean, the average score for puppy love was 2.73, and that matches that adjusted value at subscript A on our output. And I like the SPS was a little more verbose in that, because these are the means that you should report for the groups, and you should say that they are adjusted means for the covariate. And I think it's just good practice to report that they were adjusted at a value of 2.73 for our puppy love covariate. Field in his reporting doesn't really include that, but I probably would. I think it's just a little more information for the reader. Again, I'm not going to make you guys get into the nitty gritty, and this is starting to get into the nitty gritty a little bit, but I just thought I would mention it. On our answer sheet, when we are reporting our values, the one that we really care about, we already looked at our interaction and we knew it was significant, but that was part of our assessing our assumption. And we didn't really care too much about the output of the covariate. So on your answer sheet, the main effect that we care about is our dose variable, and we want our F value, and remember these are our degrees of freedom off of the Jamovi sheet. And if we went back up to our ANCOVA test dose, and we would have degrees of freedom 2 and 26, and our F value of 4.14, P value of 0.027, partial eta squared of 0.242. Now that's still a pretty big effect size for partial eta squares. And those are the numbers that we would put here. Again, if you want to do omega, you could if you wanted to do that. So that's a walkthrough on ANCOVA. It's quick and dirty. We're not going to get into more detail than that, even though there's probably more you could. But I will see you guys in office hours.